As this is Dr.Senthil Kumar, Associate Professor, Department of EEE, SNS College of Technology. Now we are sailing in the course Digital Electronics and Linear Integrated Circuits. The subject code is 23WT202, offered to second year Electrical and Electronics Engineering. Right. The topic here, it is unit number 3, design of sequential circuits. In particular, we are going to discuss about design of counters. Design of counters. In the earlier video series, we discussed about what is a sequential circuits. They are synchronous and synchronous types. Now let me see the design of counters. Here we are exploring the fundamental principles and design of synchronous counters. This is the key components in the modern digital electronics. I think that all of them having a cell phone. What you will do if a cell phone is purchased? First you have to start the operating system OS, login ID is given, and the timer, the timing device and the date and the timing comes into picture. At which time you are going to start, and the date comes into picture. Once the timing signal or switch is turned on, once the timing switch or a signal is turns on, then a counter or a timer signal, a counter is there in our cell phone which starts counting its seconds, minutes and hours. Even though there is no network, even though our network amount is zero, even though the battery is down to zero, the cell phone keeps on running the timing. The cell phone keeps on running the timing, which is nothing but a counter is there, which is nothing but a counter, a basic counter circuit is there in order to start, in order to ignite the timing pulses until the cell phone is 100% damaged. The counter counts. It is similar to our lifespan. Right? Therefore, the basic counter is in our cell phone. The basic counter circuit is in our cell phone. Right. The counters are a circuit that cycles through a specified number of states. The states may be 1 or 0. There are two types of counters, synchronous and asynchronous. Another name is parallel and ripple. The parallel counter, here the same clock pulse is applied to all the flip-flops. Whereas for your ripple counter, the output of the one flip-flop is given to the input of the second. The output of the first flip-flop is given to the input of the second flip-flop. See here, the circuit is given. Guess what is what? You mean, as per the discussion, the pink color basic building block, which is nothing but the flip flop. There are 3 flip flops are given, whereas the clock pulse is given to the first flip flop. The output of the first is given to the input of the second as a clock. The output of the second is given to the input of the third as a clock. Then it is a ripple counter. Whereas see here in the next, a pink color flip-flops. What is it? It is a parallel. Since all the clock pulse is connected parallelly to all the basic building blocks, flip-flop. For a counter circuit or for a sequential circuits, the basic building block, it is a flip-flop. A synchronous sequential device. And the design procedure, you mean how to design a counter. Therefore, the student has to think. The student has to think how to draw the state diagram first. Therefore, you have to read the problem statement first and draw the state diagram according to it. You know what is a state diagram from the flip-flop. And from the state diagram, the state table is constructed. And in the problem statement, if the flip-flop is given, then you have to choose that. Or we can choose T flip-flop, toggle flip-flop, since it is very easier to design. The fourth step is nothing but after the excitation table with the help of a T flip-flop, you have to minimize the expression using K-map. Since you have studied K-map in the unit number 2 itself, and you have to minimize the expression with the help of K-map. If the expression is and you have to realize the flip-flops and logic gates. We have to realize with the flip-flops and the logic gates the expressions. Hence, a logic circuit of a counter is established. The logic circuit of a counter is established. For practically implementation, you have to purchase the flip-flop ICs, the logic ICs, a breadboard, and a trainer kit, such that the input is given in terms of clock pulses and pulses by turning on 1 and 0 with the help of a toggle switch, and the output is verified with the help of an LED. If the LED glows, then it resembles it as 1, and if it doesn't glow, it resembles it as 0. Let me see a design in the next video. Thank you for patient listening.